So we'll see the molecular orbitals of unsaturated systems. Uh, we should know that the pericyclic reactions, all types of pericyclic reactions involve unsaturated molecules. So first we should have a pictorial uh, concept of how these molecules are formed. Okay, like about we should have an idea about the molecular orbital formations and how the hybridization is taking place and all, and we should have a pictorial uh, imagination or the pictorial idea. And for that we'll see this at the simplest unsaturated molecule, and that is CH2 double bond CH2, that is ethylene, or you can say ethene. Okay, so in this case we know that CH2 double bond CH2 has got a C double bond C, in which one bond is sigma, the other one is pi. And the sigma bonds, as we know that it is formed by the head to head interaction, whereas the pi bonds are formed by the sidewise overlapping. Okay, so we'll see in this case we can say the carbon. Okay, so we can say that the carbon and carbon, the carbon in the ground state has got 1s2 2s2 2p2, and in the excited state the electronic configuration is 1s2 2s1 2p3. Okay, that is 2s has got one electron, and this has got 2p has got 3 single electrons. And we can say in this case CH2 double bond CH2, we know that this carbon is in the sp2 hybridized state. Both the carbons are in the sp2 hybridized state, and that is possible when we have the sp2 hybrid orbitals. We have four we have the sp2 hybrid orbital, so we can represent like this. That is, these two will be combining. There is head to head overlapping. So here head to head overlapping takes place, and this is how you're getting a sigma bond. And this sp2 hybrid orbital will be combining with 1s orbital of hydrogen, and it forms a bond, a sigma bond with that of the hydrogen. Again, this will be forming a sigma bond with the hydrogen. This will be again forming a bond with the hydrogen, and this will be forming a bond with hydrogen. So in this case we can say we'll be having this much sigma bonds. Now the carbon has got a valency of 4, and in this case okay, carbon has got a valency of 4, and we can say that 3 of the valencies of carbons are satisfied over here, okay, by sigma bonds. And so here we can say this is taken up, this is taken up, and this is taken up. Now we'll be having one more orbital, and this orbital will be perpendicular to this plane. So carbon will be having one more orbital which is perpendicular to the plane, and this will be having a single pair of electron. So these together will be forming sp2, and then it has got a lone pair of electron in the p orbital, and this p orbital is found to be perpendicular to the plane of it, plane of the ethylene molecule. So we can say that this p orbital will be having 2 electrons on it. Okay, when we have 2 orbitals we can say this will be the ground state condition. That is this is sigma, then pi star, and sigma star. Okay, so it will be having, ethylene will be having 4 electrons in total. Okay, 4 electrons will be there. So since it has got 4 electrons, we can say that 2 electrons will be occupying the sigma, and the 2 electrons will be occupying the pi. Okay, so in the ground state it will be having this particular configuration. Okay, And we always consider the valence electrons, and here we can say that this is the condition. And we'll see what happens when the bond is between. Okay, we'll see what happens when the bond is between okay, so in this case we said that this is the condition. Okay, this is the condition. So in this case this is what we have represented in another way. Okay, this is what we have represented in another way. So here we have the p orbitals, and there are two possibilities. P orbital is dumbbell in shape, and therefore we can say that we have upper lobe and lower lobe. So for a overlap to take place, okay, the upper lobe both the upper lobe should have the same sign, and both the lower lobe should have the same sign. So overlapping is possible only when there is the lobes with the same sign. Okay, the lobes with opposite sign means there won't be any overlap. So when the lobes are in the same sign, we can say that it is in phase. Okay, when the lobes are in the opposite, here the positive is up and the positive is down. So when the lobes are in the opposite, it is known as the out of phase. Okay, now we can say if it is in phase means overlapping is possible. Overlapping is possible means we can say that these two can combine in this way. Okay, these two lobes can combine in this way, and that is what it is represented over here. Here these two can combine in this way for one bond to form. Okay, for one bond to form, we know that the upper lobe and lower lobe should combine. Okay, so if should overlap, that is, you have positive sign, we have positive sign. For these two combine means for a bond to form means these two should combine and these two should combine. And when upper lobe and lower lobe are combining, you get one single pi bond. Okay. So in this case we have here there is overlapping, upper overlapping and lower overlapping. So this overlapping is taking place, what is known as the additive interaction, and this resultant is known as the pi bonding molecular orbital. Earlier it was a single orbital, now it has formed a bonding molecular orbital. Okay, and when the bonding molecular orbital this is taking place, you can say that a bond is formed over there. And there is one more possibility, that is out of phase. Out of phase is having the opposite sign, lobes having opposite sign, and therefore same lobe having opposite, upper lobe have opposite sign, so it is known as a subtractive interaction. And in this case we can say that these two will be repelling. Okay, when they have opposite sign means they will be repelling, and therefore we can say that this will be moving more towards this side and this will be moving more towards this side. That is, they are repelling. So the distance between these two increases, between the lobes increases, and there is no bonding taking place, and this is known as the pi star anti-bonding molecular orbital. And here the energy is represented, and from the figure it is very much clear that this in phase has got the lower energy, and out of phase has got greater energy. When the in phase is converted to a pi bonding molecular orbital, this what it represents is that we are drawing a little down. Okay, here it is also representing the energy, that is in phase. Once it is forming the pi bonding, it will be having lower energy, and here out of phase pi star has got higher energy. Or another way of representing is that you have one particular suppose this is the energy level. So bonding in the molecular orbital, this is how you represent. Okay, this is pi bonding, there is a bonding molecular orbital, and antibonding will be having greater energy. So this was the earlier energy level, and since it is forming bonding molecular orbital, it will be having lower energy than the original one. And if it is forming the pi star, there is anti-bonding, it will be having the higher energy. This is what it is represented.